Then I ever about like breaking the groups up and having them work in groups, or was there anyone like that? You don't maybe need that, or that had a really good score? That could have been like used for it, or could have broken up in these groups and all, and they could have shared out, or maybe that would.
I mean, that could work.
I don't think there were the kids that didn't need to go over it. Maybe did they get everything? Like it could be
Different perspective.
Yo, look at this.
What's the point?
Water.
No, it's...
Gotta stay hydrated.
No, why do they have so little ones? I don't have normal ones.
Jason!
Hey, have you been website at all to figure out how to do the stuff? Make sure that you're still doing it. Because I haven't seen HS math that work. It doesn't work here. So I think you missed maybe 5 or 6 assignments. So.
Dad, how's mom still doing? Hi, your dad. I have a battle axe in my basement that's told me. So this is very tough to do your computer now. Ah, douche. I don't like you either.
Why? Because I'm wearing the shirt?
No, because you're just a fucking jackal.
Ooh. Best shirt ever, Fraser. The Uno video yesterday.
I was playing the room instead of over there.
Like Uno?
Yeah.
I was getting mad. I was putting my beer.
Uno was fun.
Uno is like the best, but I want the like real Uno.
I'm thinking about,
That's what they play?
What?
That's what they play?
yeah, I'm thinking about buying on PS4.
How much is it?
I'm like $20.
How much?
$19.99.
Oh, jeez,
Alright.
scared me.
Alright.
I thought the power went out. I was like, oh god.
Okay.
Okay.
It's
Alright, all we're going to do today is some notes, kind of fill in. Just a reminder, I'm not here tomorrow. I'm going to the AEA all day tomorrow. So tomorrow will be kind of a work day where you get to work on your assignment that we're going to talk about. We need to make sure that we talk about the prime factorization. And then we have 2 new topics that will be on the homework tomorrow for sure, which is greatest common factor and least common factor. So that'll be a part of the homework tomorrow. Okay? All right. So let's go through those types of problems right now. If you need a calculator, that'd be a good thing. We are going to get to those types of problems today, so I'll hand those out here if you need one. So have your notes out. Go through the sections that we're on. We're on section 2.7, but we're also going to go to 2.9 today, which I know is kind of weird. Why are we jumping like 3 sections to 2.7, 2.8, 2.9? We're mixing a lot of things together today. We're still doing the same topic we did yesterday, but now what we're learning is how do we apply it? What are we going to use it for eventually? And I'll show you kind of big picture ideas today. That's the idea, right? So, goal today. We are still going to use prime factorization. So that was a topic we discussed Friday and then yesterday, because I know we did maps testing. So I think anyone in here not finished other than Beth for maps testing. We finished yesterday, correct? So Beth, at some point during school holiday, you got to work with maps testing, or before school or after school. So that'd be a good thing like after school day if you're going to keep working. That'd be a good thing to work on. Okay. All right. So prime factorization. The big thing was what we talked about was it uses prime numbers. That's what we're doing. We're breaking down a digit, a single number, into prime factors only. Prime numbers. That's what we're doing. Now there's the different prime numbers. What do you guys remember from yesterday? What was the list of prime numbers?
2, 3, 5, 7, 11, 13, and 19.
7.
17 and 19 and 20.
23, and it keeps going. That's right now. How that list is made, it's not just random. It looks random, but these are numbers that you can only break break up into the number and 1. Right? Like when you try to break up the number 2, it's 2 and 1. That's the only two numbers that can multiply to give you the number 2. 5 is 5 and 1. Those are the only two numbers that multiply to give you 5. 13 and 1 are the only two numbers that multiply to give you 13. I skipped the other ones, like 4. The number 4 in here has a bunch of different factors. It has 1 and 4, but it also has 2 times 2. That's multiple factors. So those are composite numbers, not prime. These are the primes. They cannot be broken up into any other numbers other than 1 and this number itself. So our goal is to do prime factorization. Is to do a few examples of these today. How do we use these numbers? How do we use these numbers to break up a bigger digit? And what we're trying to go for, our goal on these is to do expanded form, which I'll explain today. That was the form that I know, like Collier asked me yesterday, do we have to do that? And I prefer that you do. And then exponential form. So that's using exponents. So those are the two forms I want to get to today. Okay, so we'll do a couple examples after lunch. Because I know this is going to seem like review, because it's nice to do the review. After lunch, we're going to look at the new stuff. The new stuff we're going to be looking at, and like why we use this stuff. It's like the uses for it, right? That's what we're going to talk about, the uses for how we use prime factorization. We're going to be looking at what we call a GCF and an LCM. Those are like the terms we're going to start using. Now you've probably seen those in like Algebra 1 or basic algebra in like junior high, that kind of thing, 7th, 8th grade math. But we're going to look at like why we have those. What's the point? And this stuff actually directly applies to it. That's why we do this. Some people they don't use this after general math. They don't use this strategy anymore. They don't use prime factorization because most people can do it in their head now. But I'm showing you if you're not very good at finding a GCF or an LCM, this is like the #1 way we do it, is using this. So, and we'll get to that. That'll be after lunch. Okay, but for Beth's sake, we need to do a couple of examples so that she knows what we're doing, right? Because obviously we've been doing these since Friday, so we need to kind of look at the numbers. Now, I'm going to pick kind of a bigger number, so that's why you have calculators in front of you. Let's try. Do kind of a big number here. Let's do 1764. So 1764. Okay. So what we're going to try to do, this is a big number. It's definitely composite. The reason why is, what's the last digit? 4. It's even. So we know 2 goes into it. So we know this is definitely a composite number. My goal is to break that number up into only these numbers, or a combination of these. That's the idea. And it could be multiple, like you can repeat numbers over and over and over. Okay? So that's what we're going to be doing. So we're doing what we call prime factorization. It is not a factor tree. Factor tree is where you try to think of every combination of numbers that would multiply to give you 1,764. That would take way too long. You would never want to do a factor tree for something that big. The list could be just mind-numbingly long. But prime factorization is different. So that's what we're doing today. Okay, so what's the first number we should always check? Yeah, you should always check 2, because how I know that? It's the first prime number. You always check that. Now, if 2 doesn't work, let's say you divide 1,764 divided by 2, and you use a decimal on your screen, don't use 2. Skip over it. We'll go to 3, or we'll try 5, or we'll try 7, and go in order. So let's try 2 first. So take your calculator, take 1,764, and let's divide it by 2. Now notice, I'm putting the prime number that we're trying on the left, and whatever's left over goes on the right side. So what happens if you divide it by 2? What do you get?
380.
I got 888.
That's what you get. Take 1,764 divided by
Oh,
2.
1,000.
I got 800.
I got 8.
Ooh, I messed up there.
Yeah.
I
Do that?
Yeah.
Okay. All right. So 8882. 882. Sorry. 882. Correct? Okay. Now, because that's the prime number I'm checking for. Whatever's left over goes on the right side. Now, we have to keep going. So we're gonna start with what the leftovers were, and we're gonna do it again. What number should we always check? 2. Check 2 first. So take 882, divide it by 2. 441. All right. We good with that? It was a nice whole number, right? It was no decimal. Okay, so it did work. So we can write that down. If it gave you a decimal, erase this and try the number 3 then. Okay, so now we're at this point. Now what we need to do is, I know a 2 will not go into this. The reason why, it doesn't end in an even. So 2 is done. We're done with 2's from now on. So what we should try next, let's try 3.
147.
147. Okay, all right. So 3 definitely worked. Gives us a nice whole number. So now let's try it again. So we're at this number. Now we're going to try 3 again off of the 147. Notice I'm always putting the prime numbers on the left. Say it again.
49.
49. Geez. Okay. Now 49, I know a 3 will not go into it. When you add 4 and 9, it gives you 13, 14. It gives you 13. That is not a number that 3 goes into. So 3 is done. So what we're going to need to try now, let's try 5. Does 5 go into 49?
No.
7.
Yeah.
Yeah. 7 and 7. And we're done. How I know that I'm done, it's not because these numbers repeat in the end. It's because when I was always putting the prime number on the left, the number that's left over, the minute you're done is when that number on the right side turns out to be one of these. You know you're done. So the number on the right side at the bottom, you agree it was 7, that's in my list, you're done. You can stop there. And what we do now is we circle all the prime numbers on the left side. That's why we always put the numbers on the left, including the last number. So it should look like a big hockey stick or a tube sock, whatever you want to call it. Yeah, it looks like a croquet mallet. I don't think it was a gold mallet. Cricket? Yeah, cricket mallet. Yeah, almost kind of. Yeah. Like a little knock at the end. All right. So now, those numbers, the numbers I circled, they're all primes. Agreed? They're all these numbers. What I need to do now that we've done that, I want to write those numbers out in what we call expanded form. So just write those numbers down next to each other and put a dot in between each one. So what are all the different numbers that you see here? 2, 2, 3, 3, 7, and 7. So it just happens to be some of the numbers we're repeating. Okay? So that was what you're looking at here. This is expanded form. That's what I want you to write down. That's what you'll have to do tomorrow for sure. Okay, so that's expanded form. Writing down all the numbers you circled. Just putting dots between them. Now, how do you know you did this right? Like, I don't know if this is the right number. Multiply those in your calculator. You should get the same number you circled. 1,764. That's how you know you did it right. Okay? Now, the next thing, we need to write this in, we need to put this back into exponential form. So exponential form is now where we combine these numbers into groups, right? So, because you notice that some of these numbers repeated, right? How many 2's were there? There's 2 of them. So the base number was 2, and there was 2 of them. That's what was the exponent for. How many 3's were there? There was 2 3's. So 3 with the power of 2, that means there's 2 of them, right? 7's, how many 7's did that have? 2. That's your answer. That's exponential form. Using exponents instead of writing out the full expanded form. You have to do both. So, and in fact, you have to do all 3. You have to do this prime factorization thing, expanded form, exponential form. This is breaking down numbers as far as you can. Okay, questions on how to do this? Let's try another one. Now I'm going to try to pick a number that doesn't end in 7. Let's try to pick something that doesn't. Every number we've done for the past, like, couple times, have always ended with 7.
You should do a giant number.
Big number? I won't go big, but we'll pick some numbers. Let's see. Okay, I got a big number here for you. All right, here we go. This is big. I was not expecting to do this kind of number. All right, so we're going to try to break up this prime factorization. 1, 2, 5, 4, 8, 2. So that is 1,254,825. Now we'll do another big one here in a minute. So this is the one that I want to do before lunch. What number should you check first? 2. Is 2 going to go into that thing?
No.
No. Ended with a 5. 2 plus definitely does not go into that because it ended with a 5. Okay, so now what's the next number you should check on the list? 3. Always check 3. Did 3 go into it?
Mm-mm.
3 doesn't? Sure.
We almost need a 5.
I think you should try 3 first. So we divided by 3, what do you get? Like that? Okay. So that's 418,275. And now obviously, I think most of you tried 5 first. You're fine. You're not wrong. You can keep going with your number. Okay. I like to try the smaller numbers first, so I like to do 3. Let's try 3 again. So if you're still sticking with me, that's fine. If you did 5, you were doing there, but I know 3 is going to this. So let's try 3 one more time. What do we get?
139,425.
Like that?
Yeah.
Okay. And now what should we try again? 3. You always keep going until that number doesn't work anymore. So I'm going to try 3. Because I know 2s are not working, so we're not even going to attempt 2s. But 3 starts with a 4, 6, 4, 7, 5. Okay. All right. At this point now, we're here. We should try 3 one more time. I don't think 3 is going to work. I think 3 fails. It gives you like a weird decimal on your screen, correct? So now what we should try is we should try 5 now.
Wait, why did we skip 4?
4 is not a prime. No, 4 is composite. 4 has 1, 4, and 2's in it, so it's not prime. So only the numbers you see on that list. So, all right, but let's try 5. What do we get when we divide this thing by 5?
9,295.
195.
There's a 9. Wait. I think it's
4, 6, 4, 7, 5 divided by 5.
9, 2, 9.
Yeah, 9,295.
Well, 9,295. Sorry, misheard you. 9,295. All right, and then obviously if 5 goes into it again, that's a 1, 4, 8, 2, 5, 9. Like that. Now, obviously, 5 is not going to go into that any further, so now we should try a different number. We try 7. The 7 is the next prime number. Does 7 go into the 1859 number? Not even like into a decimal. Okay, try, what's the next number? 11. Try 11. 11 did? Okay, how many times did 11 go into it? 167.
169.
Oh, 169. And 169, and try 11 one more time. I know 11 is not going to work, just because the 1, 9, and 6 don't work. 13 does. 13 times 13. You divide by 13, you get 13 out. Okay, and that's it, because the last number now is prime. We ended with the 13, which is on my prime list, so this is a big hacky sack. Or protein out, or cricket out, whatever you call it. Okay, so what's my expanded form of this thing?
3,
So say it again.
3, 3, 3, 5, hypho,
5, 11, 13, 13. That's expanded form. So writing down all the numbers we circled. As long as you're putting all the primes on the left side, you should be doing. And now, what do we get? We're now to exponential form. Exponential form. What do we have? So, how many 3s do I have? I have 3 3s. How many 5s do I have? 2. How many 11s do I have? 1. So there's our 1 there. 13s, how many do I have? 2. So there's your exponential form. Okay, questions, comments, concerns? Okay, this will be our last one before lunch. After lunch, we'll come back. Now we're going to start to look at how do we use these. How do we potentially use this to do a GCF or an LCM, and we have to define those before tomorrow. know, see, I'll be gone, so the sub will be in here just kind of telling you what your homework is, and that's pretty much about it. So. Alright, so, you know, a little bit of a break here before lunch. After lunch, we will take that from there.
One game I can beat you at.
Oh, really?
Yes.
I don't think you're actually, I mean, dude, Jason, you're a farm boy, aren't you?
Yes,
So,
Red turbine.
either tonight or tomorrow on Rocket League.
I know. Look at what you read.
Just decide what I want to do that. I'll probably will. I have like $24.99 in my current wallet.
Okay. You put a smile like that.
$24.99. Yes, $24.99 after about Raver.
What did you all ask you? Like, what's your favorite color? You're like blue, he's like brown.
I think you might buy it tonight. I can buy Uno tonight. It's not even my mom's credit card.
Really?
I have $24.99 in my current wallet.
You're like.
I had 6, but then I bought Rainbow Six Siege and I added like $24.
Go to the next Batman,
Current
dude.
wallet amount.
Hey, better watch out, the next Batman's right there.
Ooh, I know.
I can make that do a meme.
I know what you get at this. Price tag, you know.
Yeah.
Why if the thing's still open, ship it all over.
Dude, even was like this in science. Oh, you got it!
You get it once, and then you can't do it anymore.
Well, Alex can do it all day.
Well, that's because he's good at it.
Oh, good.
Dab.
Hey, I'm kidding. It's almost like you're sucking a straw but blowing it. Like that. Make that noise, but don't make a noise. It's weird to do it.
I did a couple times.
Does sound like
Loud.
water dripping.
What?
It does sound like water falling from the faucet.
Alright. Okay, let's talk about this idea of GCF and LCMs today. Let's do that. We're still doing prime factorization, this method right here. But we have to go like one more step. So let's do the definition. We'll start
I know
with
those.
one each.
I know.
So that's kind of the idea. So, okay, so hold on. Let me write these up here.
Can I do both?
Alright.
Now,
We'll just do one. Let's do one.
I know.
Alright, let's start with the GCF.
That's good.
Oh, that one's easy. I don't want to do that one. You know the one? I don't do
Yeah,
that.
I want to do the last.
Alright,
I want
so
to do that.
GCF, what does it stand for?
Greatest common factor.
Good, alright. So, greatest common factor. That's spelled right first. Greatest common factor. Alright, now, there's a couple different ways to figure out what a GCF is. Number one method is, one method you could do is you could do a factor tree for your numbers. That's the factor tree, if you don't remember, is the branching tree where you try to figure out every number that can possibly multiply to give you the bigger number. And then what you do is you circle the biggest number that they have in common. Okay? So you can do it by that method. But our goal today is to learn how to do it by prime factorization. To show you kind of the ease of it and why it's pretty straightforward and why this is actually the preferred way to do those problems. Okay? So let me give you an example here, and I'll try to do it for both. right? So let's say we're messing with the number 48, and let's say we're messing with the number 36. Okay, so these are going to be my two numbers, and usually what they do is they separate them with a comma. Okay, so on factor trees, what you do is you would make every combination of numbers that would multiply to give you 48. So like 1 and 48, 2 and 24, 3 and 16, 4 and, let's see, 4 and 12. We could go, let's see, 6 would work, 6 times 8. 5 doesn't work, and I believe that's it. 9 won't go into it. But there's 48, right? It's every combination. I don't like doing that. It takes too long, especially when your numbers are huge. That would take forever. Just imagine doing like the common factors for that problem. Why would you ever want to sit there all day long figuring every single combination of numbers that can possibly work? I would not want to do that. Okay, now, the other thing, and we're still going here, we're still doing the common factors here for 36. So 36 is 1 and 36, it's got 2 and 18, it's got 3 and, let's see if I got 3, that's 3 and 12, we got 4 and 9, 6 and 6, like those are all your combinations. Now, supposedly those are all the different numbers that we have, okay? What is the biggest number that they both have? So you'd start here, and you'd work your way around until you find the biggest number that they both have. That's it? 12. That's your greatest common factor. They both share the 12. That's the biggest number that they both have. That takes too long. It's way too long of a process. Especially, what if you forgot? Like, what if you didn't check every single number and you didn't make that whole list? That's why I like to do prime factorization. Prime factorization is actually a faster method of doing this. Getting the same digit, 12. But just doing it by the method we will talk about over there, just using prime numbers to do it. Okay, so let's take a look at this. Okay, so we're going to do 48, and we're going to do the 36. And we're going to do it for the prime factorization. In fact, I'm going to separate these out a little bit further, so you have a little bit more room to work here. Okay, so when we start prime factorization, what's the first number you should always check? 2. Notice, we're not doing factor trees. We don't use 1s, we don't use 4s or anything like that. We always check these numbers. So we try 2. 2 goes into 48. If we divide it by 2, we get 24. Then we try the same number again. So we try 2 again, because I know 2 goes into 24. Or that's 12 times you divide it. Then we try 2 again, which is 2 and 6. Then we try 2 again, if it possibly works, and it does. 2 and 3. And it looks like 3 is prime, so this is the prime factorization of that number, which is 2 to the 4th power times 3, right? Or 2 times 2 times 2, 2 times 2 times 2 times 2 times 3, right? So that's the expanded versus the more exponential, right? But for 36, we do the same thing. We break up the 36 to be 2 and 18. Then we break up the 18 to be 2 and 9. And 9 doesn't have 2 in it, so we try 3 now. 3 goes into 9, what, 3 and 3? 3 and 3. All right, and the actual, when I circle those, the actual expanded form of that is 2, 2, 3, and 3, which is 2 to the 2nd power, 3 to the 2nd power. All right, so the greatest common factor, if you're going to do it by prime factorization, so I did this, I did that. What numbers do they both have? So if you look at this list, what are the base numbers that they both share? 2s and 3s, correct? They both have 2s and 3s. Now, if this one had, 5 and 6s and that, 5s and 7s, that one has 11 and 13. You only pick the numbers that they share. They both have 2s and 3s in those final answers. So that will be a part of my GCF, that I know that they're going to have 2s and 3s in it. But now, we've got to figure out, what is the common number that they both have? This one has 4 2s, that one has 2 2s. How many do they both have? They both have 2 2s. At least 2 2s. This one has more, but they both have 2 2s. But what about the 3s? This one has 1, that one has 2. How many do they both have at least? 1. this is your answer. This literally means 2 times 2 times 3, which is 12. Same number. It's a faster process. It takes you less time, especially, and like a lot of you are looking at it going, that wasn't less time. That seemed like it took forever. If you had to do it for that problem, way less time. Way less time doing it. And it doesn't take any mental thought. Greatest common factors, you figure out the numbers they have in common, and then picking out the powers that they both have at least. They have at least, this many. They both have 2s. So it's the greatest number of things that they both share, they have in common. Okay, does that make sense?
Yep.
This is what I want you to do tomorrow. Okay, this video will be online, so if you need to rewatch this again, you can always do that for tomorrow, because I won't be here. Remember that, so I'm talking tomorrow. So you have to be able to do this on a worksheet tomorrow, for sure. Okay. Okay, let's go on to the LCM today. And I'm going to leave this up here. Let's go to the LCM. I'll definitely show you why this is the way. All right, so LCM.
Least common fact. Least
Least
common multiple.
There you go. Least common multiple. Least common multiple. Okay? We're looking for multiples of numbers. Multiples. So these numbers are bigger. I know that it seems backwards since it says the word least. What you're actually doing is you're looking for multiples on numbers. So let me give you an example here. Let's say we did, let's go, let's say we're doing like the number 77 and the number 105. Okay? So these are my two numbers, right? And usually what they do is they separate them by commas, right? All right. So they'll write them like that. And we're looking for an LCM for these numbers. It's not a greatest common factor. Okay, so we're not doing factor trees or prime factorization, which we'll do here in a minute. But for common multiple, this is one method. You could do the multiple list. Multiples list. And what that is, if you don't know what a multiples list is, it's writing out 77 times 1, 77 times 2, 77 times 3, 77 times 4. You guys get the idea what I'm doing here?
I should just try to do 77 and 105 to get the same exact number.
You can, but you're trying to find the first number that they go.
No, yeah, that's what it is.
So the problem is if you multiply 77 times 105, that number will be bigger than what you think. So you make the entire list for 77. Then you make the entire list for 105. 105, 210, 315. And then take 105 times 1, 105 times 2, 105 times 3, 105 times 4, 105 times 5. And you keep going. And what you're trying to do is find the first number that they both have, that they both run into each other. That takes way too long. Okay? But if we do it by the prime factorization of 77 and 105, now this is a way easier process, doing the prime factorization of it. So now, you got to get out of your head that we're doing common factors. So we're not doing common factors, we're not doing the else, or we're not doing the DCFs. It's going to look the same, but the end result, we look for different numbers. Okay? So, all right. For 77, obviously a 2 doesn't go into it, 3 doesn't, 4 or 5 doesn't, 7 does. 7 times 11. So that prime factorization is super easy. 7 times 11. Nice. No, that's not hard. 105, 3 goes into it. 3 is a 3, carry a 1, that's 35. Then you break down 35 to be 5 and 7. And so the prime factorization of that is 3, 5, and 7. And there's only one of each. So that's the expanded and the exponential form because there's only one. And now for the LCM is, it's not what they have in common. If you're doing GCFs, what number do they have in common? 7. That would be it. That would be the GCF, right? That's the only number that they both share. But we're doing LCMs. We're doing the common multiples. So how you do a common multiple is you pick every different number that you see. So on this list over here, what are the different numbers you see? 7 and 11, right? Over here, which are the different numbers you see? 3, 5s, and 7s.
Oh, yeah.
That is your final answer, what you're going to have. That, if you actually put all the different numbers you see together, 3s, 5s, 7s, and 11s, you put them all together, that'll be your final answer. Entities have powers. You put the power on this final answer. So if this one had like 2 7s, you put 2 7s down here. If that one had 4 11s, you put 4 11s here. You put whatever the powers are, the biggest power that you see. Because you have to put all the different numbers and the biggest powers, because you're doing multiples. So your actual number here is 3 times 5 times 7 times 11. The first number they would actually meet down the road here, I didn't even finish this problem. The first number they'd meet at, if you actually do this right, is 1,155. You see why I don't want to do that? Why I don't want to do the multiples list? Yeah, it takes way too long. I mean, it would just take forever to get there. I mean, I'm only at the 300s here. Looks like it's going up by roughly, going up 77 each time, so it's going to take me quite a while. This one's going up a lot faster. It's going up 105 times, so I'll still have to go another six numbers before I finally find one where they match, which is the 1,155. But least common multiples, it's every number plus their biggest powers. On common factors, it's just the numbers that they share. That's the big difference. Do we see that now? All right, that's it for today. So we're ending there. Now, that is not a lot of examples. I know that. We've only done one example of each. So, tomorrow, a majority of your problems, what I want you to work on, like let's say like you get here tomorrow and you don't remember how to do this. What I want you to at least do is just do the prime factorization for every problem if you can. Does that make sense? It'll tell you that. It'll ask for prime factorization. You can at least do that for every problem. And then what we can do on Friday once they get back, we can maybe do another review of how this works again. Okay, does that make sense? We'll talk about LCMs. Because at least you can do something on that worksheet if you don't remember exactly what we're doing here.
Oh, yeah.
No idea. I haven't heard. I usually get word in the morning. I drop off my lesson plans in the morning, and they usually tell me who my sub is, so no idea.
Oh, come on, baby.
Still in the trash.
I'm here. Open it. Just open it. Wow, what is it? 90 degrees. 90 degrees. There's the trash. No littering. You gotta recycle it, dude. Take it. If you go on PlayStation 2, you got trash, man. Oh, like it.
I dragged myself back.
I did that too. It was before one of our games. I was sitting there. I went to jump on the rail, and I hit, and his pest was sticking out.
I thought my scheme.
And I hit him. And I hit him. And I literally cut
Where?
right here.
Oh my god.
You really hurt yourself.
I mean, I always go catch it.
Jason, you don't catch pencils like that.
Yeah, dude.
You do?
Yeah,
So you
Well, you
catch
can.
pencils with your
I
wrist?
forget.
Yeah, I did.
Think you're gonna practice in cycle?
What, is it ready?
I'm gonna write some Uno
Yeah, if it
online.
starts drying up by the,
Inside, because volleyball.
if it
Right, call
starts
some
drying
Uno
up
online.
by the end of, oh,
showing up at the end of the day. Yeah.
You guys still have practice, right?
Yeah. Yeah, we'll still practice all week because of the tournament on Saturday.
You know, Luke Hanson has a channel with 21 subscribers.
The only day we don't practice is
I have
tomorrow.
55.
What? You saw that?
We'll practice tomorrow. We go to junior.
Game 2 though.
What's that? What's that?
Uh,